Hi everyone, good afternoon. I hope everyone still has some energy left for the rest of the sessions. No? And first off, welcome to my talk on Pythonic ways to build serverless apps in AWS and how to migrate from frameworks. So first off, a bit about myself. Hi, I'm Arnel Sarmiento. You can call me Nel. I'm from Davao City, Philippines, and I work as a Python backend engineer at Elementa. We're a fintech company based in Sydney that builds financial tooling for financial advisors there. I'm also the community lead of Durian Pi, Davao's Python user group. And much recently, we did PyCon Mini Davao, which is the very first regional conference by our user group. And also, we do monthly meetups. So if you're looking to visit the Philippines or in Davao City, just hit me up, or maybe you can join one of our meetups there. All right. Now, for this talk, I'm going to talk about Python web frameworks and why they're awesome. We're gonna dive into Python for serverless applications and the challenges in switching to serverless, while also maintaining the developer experience in the frameworks that we love. Some drawbacks on those methods and some key takeaways. So first off, want to see a show of hands. Who here has used Python web framework before? Anything? Fast API, Django, Flask. All right, so I see a majority of these. How about those who have implemented serverless Python applications? All right, so I see a few. How about this? What did you use to implement your serverless application? Lambda. How about your infrastructure as code tool? Did you use serverless framework or Terraform? Yeah, that's cool. That's cool. So yeah, I don't know about you guys, but I love Python web frameworks. They offer simplicity and flexibility. The syntax is beautiful, and the developer experience is as smooth as butter. So here's an example of a fast API code, and so you're telling me that with this just one line of code, this decorator syntax router, I can essentially expose this endpoint to the rest of the world for millions and millions of users to use. So that's magic, right? But that's not the full picture of the story. You have to deal with servers and servers at scale, right? And when you scale applications, you have to deal with different scaling strategies, vertical scaling, horizontal scaling, and eventually you will find out there is a chance that your team might encounter that provisioning your own virtual machines, your load balancers, your Kubernetes clusters might add some additional complexity to your team. So what if my team just wants to ship code fast and not want to deal with the operational overhead of scalability, right? So that brings us to serverless. So serverless is built on the idea of ultra-managed containers. So essentially, the scalability of your entire application is handled for you by your cloud service provider. So your cloud service provider will handle the provisioning and deprovisioning of infrastructures depending on your use case and your scale. So instead of paying for what you use, you pay for what your users use. And that brings us to the concept of scale to zero. And scale to zero means that when you don't have users that use your application, essentially what's going to happen is that you pay for $0, right? And if ever that you see that your application is getting traction, more traffic, your application will scale and you will be priced accordingly, depending on your user's use case. Okay, so that now you know serverless, its appeal, and you might be thinking that, wow, I want to migrate my entire Python application to serverless, right? But it's not as simple as a lift and shift of your entire code base to a different infrastructure. It's not as simple as that. Serverless has a few learning curves, okay? So in serverless, what's gonna happen is that you will be dealing with a different paradigm and a different skill set from your current Python application teams, okay? So it's not only about the code that's the issue, it's about your team's use case and your team skills. So in serverless, you see that you have this whole paradigm, the single purpose function and event-driven architecture. So what's gonna happen there is that each route of your application will be mapped to a single deployable unit, a single Lambda. And that will exist for each route that you create. Instead of your traditional Python frameworks that you have entire code base, a single monolith that hosts the different routes in your application, right? There's also the issue of serverless security. There is the OWASP Top 10, which is a consensus about the most critical risks to web applications. And luckily for us, in Python web frameworks, this is handled for us right out of the box, batteries included. Things like cross-site scripting, SQL injection attacks, things like that. But in serverless, this disappears. All right, this is not handled for you by your application, by your cloud infrastructure. You would have to deal with that on the development side of things. So you see that this reappears. No, this reappears as you still have SQL injection, but instead of having SQL injection on your server, it would now occur in your Lambda function since it's not protected by a Python web framework. There's also the issue of tooling and debugging. Who's familiar with these commands in your terminal? All right, we have a few here. Python my.py run server in Django, fast API in fast API, right? And in serverless, this disappears. You do not have a local server running on your serverless application. So what's going to happen there is that your whole development workflow shifts. What's going to happen is the traditional fast API, you make your changes, you run your local server, you test it, you check the logs if it's working properly, and that's it. It's fast. But in serverless, it goes to this. You make your changes, you deploy them, you run your deployed endpoint, which is just the HTTPS URL provided after you deploy. You test it and check on your CloudWatch in the AWS console. You make your changes if it's still working, and then deploy and test again. So you see the whole tediousness of this workflow, right? So that's one of the trade-offs that you would encounter when dealing with serverless. So in summary, these are the trade-offs. So first off, your developers must upskill to meet the requirements of a serverless workflow. Security now falls more into the hands of the developers instead of the infrastructure. So the built-in OWASP Top 10 protection now disappears, and there's now a more tedious developer feedback loop. All right, so how do we reconcile this, right? We've seen the wonders of serverless, but many things have traded off. So now let's go back. What if I tell you that there is a way for us to gain the benefits of both sides and have your cake and eat it too? So let me introduce to you the Lambdalith, this one. It's essentially an entire application, a monolith, deployed into a single Lambda function. So you can have something like Fast API deployed on a Lambda. And it's as simple as just adding this mangum library into your controller in your Fast API application, and then instantiate a mangum instance and reference the app, the Fast API app you have. So what's going to happen there is that when you deploy this is a serverless framework, by the way. You just reference app.handler into your Lambda function handler. And then after that, it works. You have essentially a whole serverless application running on Fast API. So the development workflow shifts from this tedious thing into this. So first, on your first deploy, on your first test, you make your changes and deploy them. Because of course, you're gonna have to deploy your DynamoDB tables, your databases, your S3 buckets, right? And then you run your local dev server and then test it. And then for the preceding local tests, what's gonna happen is that all of it will be running on local. It's a local test with local code with while you're testing it on remote environments, on remote resources, right? So you see now that we have retained the developer experience as compared to our we have retained the developer experience from our traditional monolith applications. And the best part here is that it provides us the automatic Swagger documentation provided by Fast API. And currently, there is no way to generate this with purely serverless applications with a single function per route paradigm. So that's one great thing of a Lambdalith for your use case. There's also Zappa. So this is a tool. I think it was developed way back in 2012. It's old, but what's gonna happen here is that with just this tool, you pip install Zappa, you run Zappa init and Zappa deploy, and you can essentially deploy an entire ASGI WSGI application to a single Lambda function with just these 3 commands. So it's really flexible and really helps you streamline your whole deployment process. Another tool that helps us in deploying serverless Python applications is Chalice, AWS Chalice. So AWS Chalice is a Python-centric serverless micro framework that allows you to deploy serverless applications on AWS. So this is a framework that AWS built themselves for developers to use. So you have your traditional Flask app, for example, here. So you have a Flask app. It gets a name from the route parameters, and then returns JSON with a key greetings and a value of hello and your name, right? So to deploy this in Chalice, you must simply replace the decorator, that single decorator in your application. So by just replacing the presentation layer of your application, you can essentially migrate your whole app into a serverless workload. But yes, it's important to remember that you have to architect your entire code base correctly so that the whole migration process of replacing those handlers would be a bit manageable for your developers. So that brings us to the concept of hexagonal architecture. So hexagonal architecture is the design pattern about creating loosely coupled components so that they can be easily replaced whenever you want to replace the services that you want. So if you want to change your routers, you can essentially loosely couple the application router to the business logic, and then replacing them would be as simple and not as hard to manage for your development. And why is it called hexagonal architecture? Well, hexagons are the bestagons. So that's a meme out there. So there's also, speaking of the tools that AWS used for Python, there's also the AWS Lambda Powertools. So Lambda Powertools is like a series of utility functions built by AWS to help you develop serverless applications. So it provides decorator syntaxes for things like tracing, logging, monitoring, and idempotency, things like that. But most importantly, it also provides a REST API decorator syntax for you. So things like this. So what's going to happen there is that Lambda Powertools provides you with an API gateway REST resolver, and all you have to do is add that decorator at the top of your function, just like Flask, just like Fast API. And what's great about this also is that it provides you the Swagger docs provided by Fast API right out of the box. So those are the tools that we can use to essentially migrate our whole application to serverless. But there are a few drawbacks here. So there is the concept of cold starts. So what cold start is essentially when a serverless function is not in use, it shuts down. And the host environment, the physical resources that that function use, is being lended to another function by another AWS user somewhere in your region. So if another invocation of your own function exists, what's gonna happen there is it wakes up the function essentially, it boots the host environment and downloads your application code. And the time it takes to do that process is really dependent on how large is your code base? So as our application grows, as our application code base scales, you might see much longer code starts. So that's one issue on serverless environments. So one key strategy to mitigate this is to essentially break down our application into different services. So you might see the concept of domain-driven design. So what we're gonna do to prevent this is break down application depending on our bounded context. If a series of routes is related to something like sales or support, we would break that down into a separate Lambda function, so that the size of our initial application will be much lower than it would be than we were to combine those different routes. So that's one strategy to mitigate the cold start problem inherent in Lambdalith paradigms. There's also the issue of vendor lock-in. So yeah, we are sort of vendor lock-in. All right, so vendor lock-in is like a phenomenon in tech where a customer becomes dependent on a specific product, and then it becomes challenging to switch to another provider. All right, so that's an issue with serverless. When you do serverless architecture, you're going to use the services provided together with your cloud service provider, your S3 buckets, your email service, your queues, your database, things like that. So if you want to switch another provider, you really have to architect, going back to the hexagonal architecture paradigm, you really have to architect our application to be loosely coupled. Also, another thing that we traded off for the sake of the Lambdalith paradigm is the fine-grained IAM permissions for our functions. So what you see there is that in the traditional serverless architecture, you can have one route to have specific IAM permissions for each resource that that route will use. For example, one post route will just do a write operation in your database, and another get route will just get the get operation in your database, right? So you have that permission for your cloud provider. But when we do Lambdaliths, what's going to happen is that you will provide everything your Lambda will use so that it will work properly. So you might see that a bad actor can utilize this to gain the privileges to certain routes that he might not have access to already. So yeah, that's something that you have to keep in mind. That's some security risk that you have to take into account when your development team will use this paradigm. All right, so some takeaways. We have learned that migrating from Python framework to serverless is challenging. We've seen the challenges in developer experience, security, and upskilling your entire development team. We've considered the Lambdalith paradigm, wherein we have our Flask API or Flask Flask application in a Lambda function. We've seen how we can easily migrate it with Zappa, and how we can do this also with Chalice and AWS Lambda Powertools. And we've seen some trade-offs considering cold starts, which can be mitigated with splitting our whole application into different functions, depending on the bounded context of each route. And we've also seen vendor lock-in as a potential trade-off for the Lambda paradigm, where you can use hexagonal architecture to mitigate that. And finally, we've seen the issue of the fine-grained permission that the Lambdalith paradigm has lacked. So your development team has to really be careful when dealing with this on the authorization on the code base level. So yes, so that's pretty much it for my talk. I have a Medium article which is like a deep dive on how to implement a Lambdalith with AWS Chalice and CDK. So it has some hands-on guides and actual code that you can write on your machine if you want to check that out. And thank you. If you want to connect, here's my profiles. So yeah, happy to take some questions.